This is the other GoPro that did not have any filtering on it, that's looking up towards the sky. And as you can see, this is kind of set for a pretty open exposure as it is, because everything is kind of whited out a little bit. So it does get better, and we do get some spectacular shots of the sun, especially when it goes into the eclipse. And so this is potentially what we were kind of looking for, because as you can see, like I said, this is pretty wide open on the aperture, and the ground is pretty whited out. And I don't know if that was on purpose or if we just happened to get it that way or not, Chris, but there's the sun, and we actually see the sun go into totality from part of this footage. Okay. All right. So while this is playing, I guess, Karen and Cami, if you want to kind of start taking off and talking about your presentation of the flat Earth model. What I will do is I'll kind of intro it here a little bit by saying that Cami has been looking at this sun-moon model that she's kind of been cogitating on for about 2 years. She has been collaborating with Karen quite a bit on this, not only this, but as well as the magnetic models. In fact, Karen is collaborating on us on a number of projects, as well as even the fiber optic gyro stuff that we're working on as well. So Karen is definitely, she's a smart woman, guys, and I listen to her because she's got some great stuff to say. And I just want to preface that I've looked at this model, and even as spatially challenged as I am, it makes sense to me. And that's a good thing that I'm even able to grasp it. So I'm going to let them present it to you guys and see what you guys think about it. And so I guess Karen and Cami, if you want to start just kind of discussing this and talking about, I guess, how the moon phases are actually manifesting in the flat Earth model as you guys have looked at it. Now, many people say that, it's impossible for this to work on the flat Earth model, but from what I'm seeing and what I've watched Cami do, this is absolutely possible. And the eclipses also would be definable in this as well. And I noticed that on your graphic, on the left side and the right side, you have your ascending node and your descending node. The ascending node astronomically has been equated to Rahu, and the descending node has been equated to K2. And just like Mark Knight, Wakey Wakey, said, these are, he doesn't believe necessarily that they are physical bodies as much as they are geometric positions that facilitate the changing of the moon phases as well as the eclipse. I hope I said that right. Karen, go ahead and take it away.
Okay, so this is a graphic that Cami and I worked on to explain how the moon phases work over the flat Earth. And here you'll see that the sun ellipse is represented as being level to the Earth plane, and the moon ellipse is tilted 5 degrees. So, and one thing about how these phases are represented here, you would have to think of it as, you're like the bottom view. You're standing at the bottom and you're looking up. So if the moon is illuminating like the side of the moon, or the sun is illuminating the side of the moon, from the bottom, you're still seeing half. I don't know if I'm explaining that right.
No, actually that makes perfect sense. And Cami
Okay.
demonstrated this around our camp during the eclipse in the evening, and she was using her flashlight. And again, you have to kind of visualize, and what Cami does is she takes a flashlight and a ball of some kind, and she'll shine the flashlight up on it at different angles to show what you are actually seeing from the ground perspective. And that's really important. You have to look at this like you're looking at it from the ground perspective, just like you actually are the sun and the moon, right?
Right. So basically what this is showing is that half of the moon theoretically is always illuminated. It's just that how it is in relationship to the sun is making it dependent on what phase you see. So in other words, when it's a new moon, as you can see here, the moon is basically below the sun, so the top of it would be illuminated, and we would be seeing the part that is not illuminated. And during the full moon, it would be the opposite, where the moon is higher in altitude than the sun, so then you would be seeing the full moon illuminated. And then so on and so forth. As it changes its orientation to the sun, you're just getting it's just getting a different perspective of that half illumination.
Yes.
From the bottom.
Yes, from the bottom. And again, this is something that Cami, she actually does this really well if she's using a ball and a flashlight. Again, it's a little bit hard to visualize on the graphic, but again,
I'll be happy to get on with the ball and a flashlight if you'd like me to. I think I can demo it somewhat. I think I can do it.
Okay.
Would you like me to try?
Sure.
Okay.
All right, and Skype.
Okay, I think we can do that.
Okay, there you go.
Hi, everybody. Say hi. Okay. So what I'm going to do is I'm just going to hold up a ball. And what we're saying is that naturally, if you were working with, and I think because we haven't covered this, it's confusing, but I do not believe that the moon is picking up sunlight. I believe it's fluorescing. I believe it's reacting off of the moon, particularly with shortwave ultraviolet and a few other things on it. And if the moon is a mineral, which would have every reason, again, if we grow it the way that we do rocks and everything on the ground, it would make sense. But what we're saying is just placement. I'm confusing it right now, but we're saying that when you have a new moon, if the sun is behind the light, it's completely not lit. But as it starts coming at a different altitude with it, you'll get your phases naturally by changing the height of the moon, like your half moon here, your full moon here, by just moving the sun higher and lower on it. So when we'll take it back to the phases, are you picking this up on camera at all?
Yeah, we're seeing it.
New moon, and we'll catch it. Your crescent's coming in, your half moon, and again, it's weird at where I've got the camera, your full moon with it lower. All I am doing on this is, I don't think it shows up on this, is if you follow the rings on the page and you move, when the moon is lower than the sun's rays, it's fluorescing the top part and you're not picking up any. The sun's going to disappear for you, especially with all the sunlight in the air. But as you move the distance and change the height of it, places of it will naturally illuminate, irradiate, and fluoresce and glow. And I believe that's what we're picking up. And I'm going to go off camera now.
Okay, I switch back to the graphic, and that's fine. So I'm going to go ahead and reshare my screen. Oops. And let's see. Let's go back to that. All right, you guys should be able to see that now. Okay, so again, back to this diagram. So anyway, when you take this all the way around and you look at it, you see the waxing crescent, the first quarter, more commonly known as the half moon, the waxing gibbous, and then when it's opposite, you see the full moon, and then back around. We've seen this cycle many times, but this actually does work on the full moon. But you have to kind of visualize the moon path as kind of undulating up and down, right? Is it the moon path or the sun path? I'm sorry, guys. Correct me if I'm wrong.
Okay, the moon path.
It is the moon path. Okay. So it's kind of undulating and it's going back and forth at what, 5 degrees plus and minus? Would that be accurate?
That's, yeah, what we're using for the 5 degrees is we're using actual observations of what they're seeing on the ground, and they are seeing a 5-degree slant. So what this picture really is if anybody looks closely at lunar eclipse nodes and pulls up any type of diagrams on here, you'll notice it's a modified eclipse node diagram. And what it's doing is it's adjusting for us living on a flat land instead of a globe. And so instead of it happening around us, it's happening on top of us, which if you did that, it would change your nodes instead of to where they X on where you see the first quarter and the last quarter. If you're looking at that, are you seeing that? Nodes are normally marked there. We're moving the nodes to where they would correctly be if you went from round to flat by saying that when your conjunctions would be where they're on top of each other from the ground, not from the side. So when you take what's visualized and adjust it, very much like if you took Aristophanes' stick experiment and adjusted it by saying if it was a globe, you would get this type of distance, and if it was flat, it would, be this distance. This would be, if you look at their node diagram, it would be interpreting it actually like you're living on a flat world, looking up instead of on a globe looking all around. And that would move the patterns up and down and be visually exactly what they're seeing. And what they see naturally creates the phases when you play with lights and objects.
Very good. Okay, and I actually get that. Of course, I've seen you do it enough times over the last couple of years that it's kind of drilled into my head. But I mean, I do get it. And, when you take it with the light and you go through every one of the phases, it absolutely works perfectly. And Cami and I have gone outside at night, and we'll look at the sun and the moon, or at sunset, or many times during the day, if the moon is visible, or at night, and we can pick out the position of each of them, and she will demonstrate that on her model. And the eclipse seems to work out perfectly well. Now, one thing I do want you to explain, Cami, and this is something that Santos Bonacci made the assertion of, is if it was the moon causing the eclipses, he said that we would have an eclipse every 29 and a half days. Tell us why that is not true.
Okay, that would not be true, because what we're doing again is we keep on going and looking at it in the heliocentric model, and it's so easy to snap to what we're trained. If you actually look at and read the cosmology that he's looking at, and I'm hoping he's watching this actually, because the Rahu and the Ketu and everything, it all matches up. It's just a little bit different interpretation of what he's looking at. But the spirograph circles, if you're looking on the screen, they're lining up right on top of each other. And you see the angles, and that angle is a height angle. Now, why that is going on, the sun's path is going over, think of it as a circular path over the tropics and the equator, and how it's maintaining that circular path. And it's primarily a circular path, right? The moon, why the sun is doing a circular path, is doing more of an egg-shaped path. It's crossing each month between and crossing over the tropics of Cancer and Capricorn, and within the month it's making more of an egg. So if you visualize the two shapes overlying, and then if you play them in motion, what you're going to get is you're going to get a spirograph type of pattern. Now, as long as the moon is outside, and again, Santos did a great job, outside of the 9 degrees or wherever you put, you're not going to pick up the eclipse. But that 9 degrees is not a height. It's a side-to-side angle. You're not picking it up side to side. The height is causing the phases, but the nodes, or think of the nodes as the spaces above and below the new and the full moon. In other words, when you see the pattern open up the most, if you see the pattern open up, again, each the sun and the moon are each doing the pattern. If they line up on top of each other or within how many degrees, you'll get the eclipse, but it's a side-to-side arrangement. It's spirographing side to side, and as soon as it goes far enough out the side, you're not seeing it at all. It's under the rays of the sun. It's a rock. It's completely washed up. It's over 3,000 miles high. I don't know how we would expect to pick it up under any photographic or visual, unless you can get the fluorescent reaction that you're picking up. But if this is an opaque material, the fluorescence is going to be contained to the top part of it. So it's the top part of the moon that's glowing.
Okay, that makes sense. So basically what it comes down to, and we talked about this in the beginning, and we all do it. This is kind of why I did the show. Why do we play by their rules? Because we are constantly confronted with the physics and the math that are sort of proving, I guess, the heliocentric model. But unfortunately, because we were all indoctrinated very much with this heliocentric line of thinking, we tend to revert back to that without even realizing that we're doing it. And when Cami and I were watching Santos's demonstration on the Sun and Moon channel, we were both thinking the same thing, and I think Karen also thought the same thing, that Santos is making a very common mistake in that he is integrating this into more of a heliocentric model. Now, as I said at the beginning of the show, the Vedic cosmology is one of a geocentric cosmology. However, they tend to follow the idea, or at least the one iteration of it that we're talking about. They tend to follow the idea and the distances to the heavenly bodies, the sun and the moon, 93 million miles, 238,000 miles. And of course, when you start increasing these distances out, to these distances, it almost is then required to have another body to intervene. However, when you bring those distances in, close in, and you put the sun and the moon close together and change the geometry a little bit, then you don't need necessarily the dark bodies or the Rahu and Ketu, and you go back to the idea of Rahu and Ketu actually then being what they were originally defined as the ascending and descending node of the moon, right? So that's kind of what we want to put across to Santos. And honestly, Santos, if you're listening, we would love to have you rebut this or talk about it, because we're not saying anything is absolute here, not by any means. We're looking at a few different models, but I tend to believe that if we keep it in the context of the flat Earth model, with the sun and the moon being the same size and roughly the same distance, then all of a sudden the Rahu and Ketu takes on a new meaning, and you don't necessarily need to have these black bodies in the model, because we have everything small and local, just like is posited in the original flat Earth models. Okay, I hope I said that right. Does that sound right to you guys?
I think you said it right. And I think also with Santos, I'm so glad he did the video, because even though I disagreed with some of the mechanics on it, I learned from some of the different things he said, and even solidified more, like when he was talking about the angles exactly. It's how closely the patterns exactly overlap with the angles. And we're saying that we pick up the eclipse. I learned from him on the things. And so I think all of us are learning from each other as we do the model. I'm so glad he did the video. Again, even when we come up with different things, and I could be wrong, somebody could learn something from pieces I did. But again, I learned from his video, so I'm glad he did it. I think that they complement each other, other than I definitely believe that the moon is going above and below the sun every month. And I believe it going below and above it is being below the rays, and going above the rays is what causes the phases that we see. Because again, I can sit there and take it and model it for you, or again, show how it's working. It's very practical.
Yes, very much so. And Karen, any further comment on that?
Yeah, I would, I really like listening to the stuff that Santos Bonacci talks about, and everybody in the Sun and Moon group as well. And when I was watching his video, one thing that really caught my attention was that they say Rahu and Ketu denote the points of intersection of the paths of the sun and the moon. And so that's what we're seeing here, that they don't necessarily have to be a dark body, up in the sky. It's just a point of intersection. And the nodes rotate just like the moon rotates and the sun rotates at a much slower pace, but they do move, which is why the eclipse don't happen in the same spot every year as well.
Right. And Cami, there was something also that you mentioned last night, as far as the positions of the sun and the moon with respect to these nodes. You were saying that, like, for example, the next eclipse is, and correct me if I'm wrong, but the next eclipse will be closer to these nodes, and therefore will have a longer duration, or something to that effect. Can you explain that?
Okay, that was my theory when listening to Santos, because it's, he again clicked in a lot of things for me in the picture. I was really glad I listened to the video and listened to his readings from the Vedic cosmology. But when he was saying where, describing where the node was and how close the sun was to the node, I'm going to project it because we have a longer eclipse in 2024, an over 4-minute eclipse instead of a 2-minute eclipse. I'm going to say that where they were, Rahu was how many degrees away this time? It went from 24 to 28 degrees. Is that correct?
Something like that. And,
something like that.
Don't hold us to that, people.
We're not going to hold it to us, but I'm going to project the longer the eclipse we have, the closer it's going to be to that point. That when you get within certain angles of that point, you get the full eclipse. And I'm going to guess that our next eclipse in 2024, which lasts almost double duration and hitting to the south of here, I'm going to guess that the projecting, what I'm looking at and visually seeing with my model, I would have to project that if you took the ephemeris, it's going to be a much closer angle in on the Rahu point and where the eclipse was. We know if it gets within a certain step, we get a total eclipse. I'm saying the closest to the center we get of that node, the longer the eclipse would be. And I don't know if Adam would be able to back me up on that easy or do it. It was just a projection because I was visualizing why Santos was talking, but I'm sure that's how I see it. Or I'm not sure, but I'm sure that's how I see it working.
It'd be easy to figure out if you just pulled up the astrological chart and you found a time and the city and the place of totality. You could pull it up real easy and find it.
Exactly. So that's one of our homeworks to do, but that would be how the model would project. And then again, you run your circles and they're on 18-year cycles. And they would, again, produce the 18 cycle of eclipses, but you would see with your spirograph circles, again, do them side to side, keeping the up and down, exactly be able to predict the eclipses in pattern, in cycles. They're very secular.